Okay, so my name is Kristopher Perez. I'm in the 10th grade. I attend Da Vinci Design. I will now be presenting on math and chemistry PoL. So I will begin with math and then move on to chemistry. So this is my homework completion chart for math, and as you can see, I got all fours on homework because for the homework it's just easy because I can look at notes and I can get help. But like when it comes to tests, it's kind of harder. And I did all the homework and I get the content sometimes. Like so, if I need any help, I can look at just like the notes and then the assessment scores. So my assessments they're like I got a 3, a 1, 2.5, and a 1.5. I don't really do that good on tests because like when it comes to a lot of pressure, I just tend to just shut down and forget everything. And I try, but like most of the time I don't study. And if I do, then I just try to look at notes, but I still don't really get the content sometimes. My effort on homework and tests. Like I said before, I put a lot of effort and do all my homework, but when it comes to tests, I usually do not like study. I do try, but I can't really do good on tests. Like, it's just a lot of pressure that I have. And then when I don't get something, I usually try to figure it out alone. So that's when I start to mess up even more. And I do put a lot of effort in this class overall, but when it comes to tests, I just get lazy and I don't feel like studying at all. And when I get lost in a piece of like content, I usually just tend to just zone off instead of asking for help. The essential skill 2, just on triangles. So this is one of the quiz problems. It's 2A and 2B. So I got this problem wrong because I wasn't sure how to do it, so I was trying to figure out how to fix it. Seeing the triangle is equilateral and its sides are all 60, so since the sides are all 60, it's M angle 1 is 60 degrees angle, and the second angle is a 45, 90 triangle, which is an isosceles, so the angle would be a 45 degrees angle. And then I chose quiz problem number 4. So I got this problem wrong because I used the wrong equation. You're supposed to use the 45, 90 equation where L equals L. So when you do that, the correct answer is 210 square root 2. And then for the test, test 1, part 1, problem 1. In this problem, I needed to figure out the sides, and I found 2 of them, but I didn't get one of the triangles because I thought it was a right triangle because it has a 90 degree angle. So I thought it was going to be a right triangle, but when I saw the rest of the sides, then I saw that it was a scalene because it has different sides. And then test 1, part 1, problem number 3. So I got this problem wrong because I got confused on 2 of the angles. And when you look at the triangle, you add 73, 43 and 62 to get 180. So angle 5, one of the ones that I got wrong, is 73. And for angle 4, you add angle 3 and 70. You subtract by 180, and then you get angle 4, which is 45. Grade defense. What grade do I deserve? I think I deserve a B in this class because I put in a lot of effort, but just when it comes like overall, but when it comes to tests, then I tend to just like fail. I will try harder next year by asking a lot of questions and coming to some more office hours for when it comes to doing tests and when I start doing tests. And what grade do I currently have? I have a C in your class right now. And then I will now begin the chemistry part of the field. So I will be doing it on 2A, the atom structure and nuclear chemistry. So an atom is the smallest basic unit of a chemical element. An atom is made up of electrons, protons, neutrons, and empty space. So the nucleus is smaller than the atom. It's made up of protons and neutrons, which are heavy, and electrons, which are light. 2B, atom structure and nuclear chemistry. So we start from the beginning, which is just the atom. So the plum pudding model is basically they think that it's just made of fluids. You can't really see what it says. Electrons negative, and the electrons are negative. And the solid sphere model, which is the atom is basically it's right here. It's just a solid just a solid sphere and it can't be divided up. And then the proton-neutron model, which is right here, is the nucleus in the atom contains protons and neutrons. So on the inside, the protons are heavy and positive, the neutrons are neutral and heavy, and then the electrons are negative and light. And then there's the nuclear model, which is up here. The atom is divided into nucleus and electrons, and it is mostly just empty space. And this is the continue to point B. So J.J. Thomson, he passed a stream of electric current through many types of atoms in a vacuum tube. So as you can see in the picture, the electrons were negative, so when he shot it, it went up because it was attracted to the positive. And then Ernest Rutherford, he discovered the nucleus in the middle of the atom because when he shot particles at it, some bounced back. And then there's Rutherford and Chadwick. Rutherford fired particles at nitrogen and it produced protons, and Chadwick shot particles at beryllium metal, and he discovers neutrons because when he shot it, it made neutral particles. 2.C. Protons and neutrons in the nucleus are held together by strong nuclear force. Neutrons and protons are close together, so it makes the nuclear force stronger. So here's an example of a positive nucleus. The nucleus force is stronger because the electric magnetic force only makes them attract each other, and the electric magnetic force allows the particles to either attract or repel depending on if they're positive or negative. And this 2.D. Some isotopes are radioactive because they emit radiation. For example, uranium-238 emitted radiation and became thorium-234, and thorium-234 emitted radiation and became I can't pronounce that word. Proactinium-234. So they would emit radiation until they become stable or non-radioactive. And then for 2.E, alpha decay. In alpha decay, you basically just add 4, and it's stopped by tissue, absorbed by thin sheets of paper. For example, radium-225 plus 4, and then you get 229, and then it becomes thorium. And then for beta decay, the mass doesn't change, but the atomic number goes up by 1. You can't get through thick cardboard or aluminum. So an example is Protactinium-233, and then it goes up by 1, and it becomes 92 uranium. And then for gamma decay, everything stays the same. It can get through most materials. It is absorbed by lead or concrete. So if you have 14 nitrogen plus, it stays the same. So it's 14 nitrogen. And then that's the end. Thank you for listening.